in part 2, talking about compounds, mixtures, and reactions, we're going to concentrate on the reaction part of it. So how can we change matter into new substances? Well, chemical reactions, which are also known as chemical change, we talked about that in class, is a change in a substance or substances that then results in a completely new and different substance. So, for example, if I get 2 hydrogen molecules reacting with oxygen, I'm going to come out with liquid water. It's just the way a chemical reaction happens. So notice the reactants, this is what we're going to find on the left side, are the substances you start with. They're going to combine to form a new substance, what's found on the right side of the arrow, which is called the product. So I have reactants and I have products. They're separated by an arrow. So how do we know if a chemical reaction has occurred? Well, there's 5 main indicators of this. In a chemical reaction, we might have the evolution of a gas, meaning the creation of a gas. This is when you see smoke from a fire burning. You might have evolution of light. That's that light that fire puts out. Tells me that a chemical change or a chemical reaction is going on. Evolution of heat. Again, fire creates heat. It's a great way to talk about this chemical reaction. Color change. Something changes from maybe being a clear liquid to being a color liquid. And finally, something called the formation or the evolution of a precipitate. Now, what a precipitate is a solid or an insoluble substance that results that is formed, I should say, as the result of a chemical reaction. So, a precipitate is this insoluble substance that's produced through a chemical reaction. So why do they occur? Why do chemical reactions actually occur? Well, they occur to produce a more stable product than the existing reactants. Reactants, remember, are what we start with. Product is what we end up with. So, for example, if I take 2 sodium and I react that with chlorine, I'm going to end up with 2 molecules of salt. Well, remember we talked about sodium and chlorine both being unstable. Sodium is highly flammable. Chlorine is a toxic gas. Alone, we don't want to deal with either of them, but when we put them together, we get this very stable molecule of salt. It's important to understand, though, that products are going to have a completely different set of properties than what the reactants are. Sodium and chlorine have very different properties than what salt, the end product, actually comes out with. So where does matter go? This is something I really want to emphasize. It's important to understand that when matter undergoes a chemical reaction or a chemical change, it does not disappear or appear. It doesn't go away. The atoms are just rearranged to form new bonds, but no matter is going to be lost or gained. If I burn a piece of paper, I come out with ash, and I come out with water vapor, and I come out with carbon dioxide, but I haven't lost any matter in that reaction. This is called the law of conservation of matter. This is something we're going to be practicing a lot with in class and understanding that we don't create or destroy matter. It just changes form. That's what law of conservation of matter actually means. So what kind of chemical reactions will you experience? All kinds of things going on a daily basis. When acidic milk and baking soda come together, they produce carbon dioxide, and a lot of times this is what's used to bake a cake. Paper burning, this is what gives us ashes, the ash that's left over. Carbon dioxide, water vapor all show up. Hydrogen peroxide, you might have used this before to clean any cuts or bruises or stuff like that. It will decompose. When it evaporates, it decomposes. It's going to produce just plain old water and plain oxygen. Lots of different chemical reactions are going on in your life every day. Inside your body, there are reactions going on. In your kitchen at home, there are chemical reactions going on. We're going to be practicing with several of these in class so that you can see how a reaction occurs and what to look for to know that a reaction has occurred.